We'll be starting shortly, but just wanted to say thank you guys for joining me today.
Of
Um,
course.
I'm pretty sure Julia will be doing the recording and you'll be sent a copy shortly after we complete this. And then
Great.
I believe we'll also have something on YouTube. We'll send you a link of that.
Perfect.
Great.
Thank you.
Yeah. It seems like we've started to slow down in terms of the number of people jumping into this call. So, without much further ado, give me one more minute and then we'll begin.
Perfect.
All right. We are recording and we'll begin. So, attendees, welcome and thank you for joining us today for our discussion on battery sustainability and defining battery sustainability. Today, I welcome our two panelists to help us understand the diverse perspectives on what is needed to ensure sustainable battery supply chains while minimizing waste, emissions, and pollution. I encourage you all to submit your questions as we proceed through the discussion. We will be going over a brief Q&A afterwards with the panelists and taking in your questions. So let me start with introducing our panelists. The first one, Emily Klein, is a materials scientist and engineer at Element. She received her graduate degree in materials science and engineering at Georgia Institute of Technology, where she focused her research on lithium ion, lithium metal, solid state, liquid metal, and alloy anode batteries. Now, at Element, she uses failure analysis techniques to determine the root cause of battery failure, conducts safety reviews, verifies the authenticity of battery cells, and creates customized test plans. Our next panelist is Randy Cooper. He is the Vice President of Technical Operations and Standards at the Association of Home Appliance Manufacturers. He is the staff coordinator for technical activities on certification, product safety, and technical and trade issues, and coordinates AHAM's product safety and liability conferences. With over 27 years of experience working with major appliance manufacturers like Maytag and Whirlpool prior to coming to AHAM, Andy will bring invaluable perspective to this discussion. So, panelists, thank you for joining us today. Over the past decade, and I'll start off with this, over the past decade, we have witnessed a sudden increase in interest in battery technology as a pathway to decarbonization. Heightened reliance on battery technology poses distinct challenges, from the extraction of critical materials to the disposal of spent batteries. Establishing the chains of custody, enabling recycling, and second life reuse have been proposed by the National Renewable Energy Laboratory and the Global Battery Alliance, just to name a few, as steps towards improving battery sustainability. So my first question will be to you, Emily. Among these steps I've mentioned, where do you believe the testing, inspection, and certification sector can be best postured in addressing questions of sustainability? And where do you believe the greatest challenges lie?
Awesome. Thank you, Ben, for that great intro. And it is a really good question to ask is, as from the testing sector, where do we really stand? And I think one of the main things to think about with this is education for consumers. So right now in the battery industry, consumers really have to take accountability for what they're doing with their cells after they're done with them. And when we see cells that come into the testing facility and we're doing inspections and certification, we have a really unique perspective on what's coming into the market before consumers see it and where are we seeing changes with the technology. And really, we want to help educate consumers and product manufacturers on what we're seeing. And this is also one of the biggest challenges because getting that information out to the general public is really difficult. And we try to work with local schools to start with kids in elementary school and middle school on recycling and what the proper procedures are, but it's still really challenging. And we really have to consider how we want the battery and product manufacturers to be involved in this process. And I really like to compare it to the soda industry with plastics. And right now, a manufacturer of soda or any kind of plastic bottle can put it out into the marketplace. And at that point, it's the consumer's choice or responsibility, however they want to see it, what they want to do with that plastic bottle afterwards. And do we want the battery industry to be the same or different? Do we want to hold producers more accountable for this? And there's pros and cons with each, but it's important to consider kind of where we want to stand in this industry when we're looking at that.
Thank you. And we're going to move over to Randy real quick. So Randy, while the transportation sector and growing demand for plug-in electric vehicles has received a lot of attention for their increasing use of batteries, the household appliance manufacturing sector has a long history of leveraging battery technology for an array of applications, both industrial batteries, but also end-use product batteries. So from your perspective, what is battery sustainability, and what does improving battery sustainability exactly involve, in your opinion?
Okay. Thank you, Benjamin. Appreciate being able to be invited here today. And I'm going to start with a selfless plug here first, just talking generally about the home appliance industry. We are a leader in environmental excellence. Innovations over time have led to significant efficiency gains, dramatically reduced energy and water. Clothes washers hold 40% more volume than they did in 2000 while using less water. The average amount of water in a dishwasher cycle is 44% less than 2005, and most refrigerators use less than half of the energy of models sold 25 years ago. So again, when we look at sustainability and what we're trying to do, the appliance industry has done a lot of things from that standpoint. We're talking end products, and so I'll switch now to batteries, because we really have not really focused on this. And to Emily's point, we're not talking to consumers about that. So we'll be talking about today what we could be doing better in this area. But we've published sustainability standards for end products, but we've, again, done nothing on batteries. And when we did that previously, it was with UL Environment and the CSA group, so both US and Canada. But again, we have not done anything around that. So the question then is what would this look like, or what is battery sustainability, at least from an appliance perspective? And so really starting at the highest level, sustainability is ultimately circular economy based. So any steps along the value chain that moves towards circularity in batteries is a positive step towards that battery sustainability. So things that would be talking about would be ensuring safe extraction. This gets even in, I'm sure somewhere along this panel we'll get into the social aspects of raw material extraction, and having the influence on some of the typical battery materials. Supply chain transparency. So for both that social issue, but also the environmental issue, potential conflict, mineral management. To Emily's point, improving collection rates. We need to look at that, what we can do within the appliance industry from that standpoint. We also want to ensure new batteries are incorporating recycled content from old batteries. Again, just like we have gone into the plastics that use a certain amount of recycled content, batteries should be using recycled content. Now, this raises significant safety concerns, and that needs to be worked through. We'll highlight that throughout this panel, that as we move forward on sustainability, we got to make sure that safety is looked at and any unintended consequences are found before it's brought to market. But other aspects of what we see battery sustainability meaning is, we talked about the critical materials, but potentially that's making sure that they're within country. So North America, whether it's recycling and remanufacturing, as well as original battery manufacturing, we see the need to really look at reshoring of some of this technology. And then lastly, longevity of the battery in the original application. So stretching the life of that battery, making it last longer, obviously is helping sustainability. And then looking into that second life. And we talk about circular design principles, with recycling as the last of those design principles. And I'll just highlight that a lot of our small appliance companies that are doing the batteries reference the Ellen MacArthur Foundation graphic on circular design. Again, I can make that available if anybody's interested, or a link to that.
Absolutely, that'd be a great resource. And helping understand that circular battery economy is going to be really important because there's so many steps in it. Switching a little bit, but keeping similar question to the previous one for you, Emily. Recently, there's been that greater push towards repurposing and recycling EV batteries. However, batteries for consumer appliance and electronics, such as lithium-ion battery types, have been on the market for a longer time and have faced challenges to larger scale recycling or repurposing. What are some of the key factors that make batteries for consumer electronics and home appliances a little bit more difficult or challenging to repurpose or recycle?
That's a great question. And I really have to give credit to the EV industry for kind of escalating this issue. Because I think before, for general consumers, having lithium ion cells in their products, it could kind of go under the radar. They may not have even known that they had that many lithium ion cells in their home. But really, when you're looking at EV that has thousands of cells, we really have to start focusing on the issue of what are we going to do with these cells at the end? How are we going to try to make this economy around either lithium ion cells or new chemistries be as functional as possible? And as Randy touched on, there's a lot of different aspects that make recycling and sustainability with smaller products more difficult. And traceability and consumer knowledge, again, is really key. And they may, depending on the person, they may not be aware of the lithium ion cell in their product, or they may not know proper disposal methods. So the EPA recommends either sending electronic devices to a certified electronics retailer or a participating retailer. So Home Depot, Lowe's, Best Buy, they all have these drop-off stations that you can put your products in, or working with contacting your local solid waste and hazardous disposal. But these are all extra things that a consumer has to do to properly recycle their cell. And any kind of hindrance that we make in the process to make this more difficult for people makes them not want to do it. And we need to get them involved and get them excited about something like this and kind of show them the benefits of recycling in that way. And especially with consumer products, either whether they know the cell is in there or they don't, we really want to take action on making sure that, if the cells are going to be reused somewhere, that's not something that we want the consumer necessarily doing. I know there's a lot of videos on YouTube of people taking out cells out of their products, either the computers, or I've seen people even do it with EV packs. And it's not recommended, but some people are taking that initiative to try to, take sustainability in their own hands. But that's also something we might want to caution against. And again, it's back to that education piece.
As Randy explained earlier, safety and sustainability are very interconnected, and then there's costs and benefits on either end of the spectrum. As we aim to do stuff at home, might risk some safety concerns. Randy, I'm going to take this question over to you. You spoke a little bit how the manufacturers of home appliances are preparing and participating in efforts to improve sustainability for battery supply chains. Are there any regulations in place that you could speak of?
Yes, and there's not a lot, but there are some. And so as we look at California is the biggest one where batteries are included in their e-waste program. So as Emily was saying, consumers expected to place that in a certain bin that gets brought through that process. Not a lot of others in the US have any requirements. The District of Columbia has recently added a extended producer responsibilities for batteries, no upfront costs. Producers just join call to recycle. Consumers place batteries in a box, which is brought back to call to recycle, and then bills the producer back for that service. So again, not a lot there. And DC is obviously very, very small with just 1 million people. In terms of other pending legislation, we've got New York and Washington State considering measures, but none of those look like they're going to pass this year. And then in Canada, they also have EPR programs for batteries, but it really depends on the size. And when we talk about some future things here, we'll get into that size aspect. But they really don't have any programs for embedded batteries as well. So that's kind of a current clause that appliances have, is if the battery is inside the product, basically is not treated as needs to be recycled. It's a separate, what we'll call a common battery pack. Those are the ones that are being focused on. But now as we look at these regulations and kind of participating in looking at the efforts of sustainability, obviously on the horizon, the US is looking at the EU battery directive that has come out recently. And really, if you're not familiar with that, I'll just give you a little bit of a high-level look. This is the first time that new requirements will require the entire lithium battery life cycle, from the extraction of raw material to production. It also includes design, labeling, traceability, collection, recycling, and reuse. So they've set up 6 categories in the EU. 2 of those we are very interested in because they're related to appliances. One being portable and sealed batteries weighing 5 kilograms or less. Or second, portable batteries for general use, rechargeable and non-rechargeable. But this directive is going to guide many manufacturers, and they'll have to be passing those requirements on to battery suppliers. So this is where we start looking at that whole supply chain. So obviously the capability to ensure all batteries in the appliance are user replaceable and proper disposal will be needed and will have an immediate impact. And then the longer term use of the recycled materials and new batteries, higher efficiency, battery energy efficiency, and the longer lifetime will be looked at. So lastly, in preparation for some of those EU requirements going global or maybe being picked up regionally by some state or provincial area, some of the most proactive supplier companies within AHAM have done an RCS global battery supply chain audit in an attempt to understand the status of those supply chains, going all the way back into the 5 tiers within their supply chain. So again, a lot of preparation, not a lot of regulations right now, but again, a lot of wheels are starting to turn in this area.
Absolutely. Well, thank you for giving us a rough outline of what regulations are present. I'm going to switch over to you, Emily, real quick. And one of the questions that I'm having following the lack of effective regulations currently on the book is, what are some of the challenges and opportunities for the testing, inspection, and certification sector with regard to increasing their participation in the circular economy for batteries? How can maybe the private sector kind of lead this way?
Gotcha. So especially I'll kind of focus on my lab to kind of set the tone for this. So in my facility, we do performance and abuse testing for tens of thousands of batteries per year. And that's just in my lab outside of Atlanta. We also do, EV testing in Michigan, that kind of thing. And especially for us, because we run through so many different cells, it's really critical for us to be a part of the circular economy in the best way possible. So we frequently every year talk to our battery recyclers that we're working with and look at new battery recyclers that have come to the area. We had started talks with Ascend Elements because they moved into Georgia recently, and we kind of want to get to know our neighbor and see how we can collaborate with them. So that's been really exciting. But especially in the testing and inspection and certification, because we're involved in this process and we're working with so many cells, it's really important for us to make sure that what we have tested gets to the proper disposal method. So whether that's either single cells and they can be recycled a little bit easier because you don't have to do any product tear down or anything like that. We also have it a little easier because we can request material specific information on the cells. So it makes it a little bit easier for us to send it to the proper recycling facility and kind of maximize what materials we're getting out of the batteries when we're done with them. But that's not something a general consumer may have the luxury of doing, especially from, smaller electronics. There's a lot more steps that has to go into, whether they're getting handled appropriately. So it's either taking them out of the product, which can sometimes be difficult because in some products you don't have access or easy access to the cells. And then they need to be sorted and discharged by a reputable facility and then sent out. So when we're looking at opportunities for our sector to kind of get more involved with the circular economy, we might be able to use that knowledge that we have of recycling batteries and what we're doing to handle them to kind of help educate either other companies or larger areas where people are using more cells on how they can properly dispose of their batteries and the different options that they have, because there are a lot of different options and you can kind of choose what you want to get out of your battery at the end.
Yeah, hopefully we'll be able to talk a little bit more about some of those recycling methods near the end. They're pretty interesting, but very complex and have certain distinct benefits and costs when it comes to a wide array of different impacts. Randy, my question is, you kind of touched on it before, but I was hoping you could expand upon it. Like, what types of batteries are most frequently used for home appliances? And then could you give advice or guidance to consumers on how and where they should possibly recycle or dispose of these batteries?
Yes, the lithium chemistries are our most popular, whether that's a recyclable or just a one-time use battery. Many companies are providing a QR code or a web link in their manual to do that. And everybody is saying follow the manufacturer's instructions for this disposal, which would link back to that QR code. But I think even though we're doing that, I'm going to pick up on what Emily said before, is consumers aren't necessarily doing these things. Even telling the consumer to send their complete unit back to the manufacturer, but the manufacturers aren't getting those units back at the end of life. So as we look at this circular process, we're not seeing that, as well as we're not seeing a very high intake of the batteries, even though they're being told to take them back to a recycling center, of those coming in. So whether it's the analogy again that Emily used on Coke bottles, where the soft drink industry is trying to say we're trying to get back X% of our bottles. Again, we have not established a metric yet for what's the percentage of batteries we want to try to get back. But again, that's the information's there. We just need, it looks like, do a better job of educating and then helping drive that consumer education around proper disposal.
Yeah, we've noticed that the complexity of batteries is a very big dynamic when it comes to trying to establish a circular economy. So Emily, from your work, you've been involved in the testing and verification of many types of batteries with a diverse range of chemistries and designs. So could you help us understand, how does battery design and chemistry impact the ability of batteries to be recycled or possibly repurposed?
Definitely. So one of the great things about batteries as a whole, and especially lithium ion batteries, is the general design of them stays pretty consistent. You have your anode, your cathode, your separator, and your electrolyte. Now, the material components of those four things can change, but for the most part, that's what you're looking at. So in terms of, shredding and disassembly of cells, that part can kind of stay the same, as you just need to pull those, separate those components out, and then you can start dealing with them. But when we start looking at different cell options, that's where things get a little bit more complicated. So right now, recycling is really targeted to work with traditional lithium ion cells. So you have your graphite on your copper, you have your cathode that can be LFP, NCA, NMC on your aluminum, and then you have your other cell components attached to that. Now, with new designs that come in, we've seen a lot of interesting things come through the door that I've been shocked by. One of which was, there's been kind of this push to maybe stop using copper to be more sustainable. And that's great. And we want to look at that direction of maybe we can use aluminum on both sides or steel or something a little bit, more environmentally friendly. But then you have to look at the recycling side. So if we're used to working with copper, now, how do we recycle an anode on aluminum or any other material? How does that change? So there's kind of this domino effect that happens when people start changing designs and making them more sustainable, as the recycling industry always kind of has to catch up. And we've seen that a lot of really good companies actually work directly with recycling manufacturers right off the bat, which has been awesome. Kind of getting ahead of it and wanting to be proactive about their sustainability as a company and as a whole. And so once these cells get to the facility, I kind of mentioned before, they go through the shredding, and there's kind of like this black mass that's almost created if they get off the cathode. And in the past, it was just kind of this black mass. There weren't a whole lot of applications for it, but as we've made more progress in this field and more research has been done, we can actually turn that black mass or the electrode material that we take from batteries and use it in batteries again, which is really exciting. Because I think in the beginning, we were kind of just salvaging the materials as a whole. So a lot of the different recycling processes, whether it's, sieving, magnetic separation, you have your hydro and pyro processes, which I think if you're in the recycling field, you're probably focused on those a lot, leaching and electrochemical processes. And that was really just to try to get out the most costly materials, because the ones that we're having to might have some questionable mining practices surrounding them, or they're worth the most money, that's what people want to get out, because in the end it is an industry of money and people want to get their money back if they can. And so they were just looking at getting the metals back, but now we have new companies coming in saying, oh wait, we can actually take this cathode, reuse it and repurpose it and make it into another cathode to resell. So you kind of have that direct line back to batteries again, which is really great to see. Ascend Elements is, when we've talked to them, that's something they've been focusing on. I'll give them a shout out today because they've been very great. But with new chemistries kind of outside the lithium ion spectrum, that's where things start to get a little bit more complicated. So you have your lithium metal that's been proposed, solid state silicon. All of these new chemistries are, to Randy's point, really great for extending the lifetime of a cell, which is something we really want to do. Because in the end, if you are able to use a product longer, that's really sustainable. That's kind of what we want. If we had a battery that never went bad and people wanted to keep that product forever, that's amazing. Right now, we're not there yet, clearly, but we could be getting there. So these new, chemistries, if they're more sustainable and they last longer, maybe that's something that we can. There's so many different components to this, but now, do they need to have a separate recycling facility? How does that change the recycling tree that we're looking at? Does it make it more difficult than it should be? Are we actually going to be able to get the materials out that we want? So silicon isn't one of the benefits, is it's so abundant, but that makes it less likely to be desired to be recycled. So there's just so many different aspects to kind of look at this, and I don't want to take up too much time going down a deep dive into it, but if we touch on it later, that would be interesting.
Awesome. Well, thank you. And thank you for highlighting some of those different recycling methods and methodologies. That's increasingly important as we're trying to aim to incentivize more recycling, but the most established one, which we might touch on later, pyrometallurgy, that one has certain costs associated with it. But I'm going to switch over to Randy real quick, because I think you touched on this, the rate of innovation and certain new battery chemistries coming online. So given the rate of innovation when it comes to battery design and chemistries, Randy, do you believe greater standardization could facilitate greater levels of recycling or repurposing? Or do you believe that this standardization might hamper the fact that we want to really extend that primary use life, and really that should be a driver of this industry, because later on we're looking at recycling, taking, or repurposing of some batteries being extended well beyond the anticipated life. So should that extension of the primary life take priority?
Well, I'll first start with standards. Yes, obviously I'm a standards engineer, so I support that and really see the real kind of purpose and drive in that improvement process that you can get from standards. With all of this and all of these chemistries, though, I'm gonna come back and say we need to make sure that we have the right safety things in place. So the safety standards work needs to be definitely leading on all of these new technologies and that effort. With that, I'm going to use an analogy here that if you want a car to go fast, so if we want to get to sustainability fast, what you need to do is have good brakes, because you've got to be able to stop, and you've got to make sure that that car is slowing down when appropriate. And that's the exact same thing with the safety standard work on these new technologies. Is it's going to keep the boundaries or make sure that these things fail in the appropriate way with these new technologies. So that's definitely a key part of standardization activities. And say there is a significant amount of efforts going in standardization with this, and then taking just a battery and looking how does that go into an end product with that. So from the whole holistic aspect. Obviously, then as you look at some of these other aspects of recycling and processes, wherever you have that and you want to have standard work, you can think of a standard being the process to get that done.
Thank you. And I think you kind of highlighted some of the challenges when it comes to greater standardization as well. So to follow that up, Emily, there are a number of standards related to the safe handling and transport of batteries, as well as guidelines for facilities when in evaluating the viabilities of batteries, let's say for reuse. But from your perspective, would industry or product-specific battery standardization facilitate the assessment of batteries for reuse and recycle? Is that an important step in the way?
So I'll pivot that question a little bit, but as a test lab, we have the luxury of hearing the opinions from either product manufacturers or cell suppliers on their different opinions around cell standardization. So I'll kind of take this time to kind of reiterate what they've told us to give people a little bit more insight into their opinions on it, because there's a lot of back and forth on this topic of cell standardization and where people stand on it. And in the end, as a testing facility, we want to be around to test the risks that will still be there regardless. But some of the things we've heard is that with safety concerns, so right to repair, which drives, I would say, a decent amount of standardization discussions. Standardization for some people or some clients we've heard said that it could lead to misuse. So if you have a cell that's the same across the whole board, and you have a product that you've produced with this particular cell and you're selling replacements for it, your legitimate cell might be more expensive than, say, another one on the market that could also fit in the product, but maybe it's not the cell that you've tested in your product, or it could be a counterfeit cell, which is also a pretty big thing that we're seeing now. So it's one thing that they want to look at, is if you give a consumer the right to go in and replace what they want in their product, are they going to do it the right way? Are they going to do it safely and replace it with the cell that you want them to? So it's kind of the handling of batteries on the consumer side is the concern that people have with that. But in the end, the other side of it is self-standardization makes things easier for some product manufacturers. So some products, the battery is one of the last things that they design. You know, for a lot of cell phones, that they'll kind of design the whole phone and they'll have a certain space left, whether it's an L shape or rectangle or circle, really anything, and they'll fit the battery that they want in it. And they'll spend a lot of time designing this battery, getting a lot of life out of it and really high performance. And that's one of the selling points of their product. And they don't want to lose that if they go to cell standardization. So that's one of the other things we're looking at, is how can we still, you know, increase growth and everything and still make everyone happy, which might be impossible, but there's a lot of different areas to think about it. And as a testing lab, we want to make sure that any of the clients we work with, whether they're pro or against cell standardization, have the information they need to move forward. So if we are looking at, say, in some cases, before cell standardization, we've worked with clients that have battery replaceable products to some extent. And they'll go through and have us look at the other batteries on the market that can also go into their product to see, okay, if a consumer is going to go out there and not use our battery, what if they use somebody else's? What could happen? Do we need to take any action to make sure that people can or cannot do this? Or, you know, what are the risks that we need to have on the packaging? So we'll do testing for them, and in some cases everything might be fine. In other cases there is a bad battery out there, or a battery that didn't have great performance that flagged some concerns for us during our safety and design reviews, and we have to let them know. And the product manufacturer at that point will go back with that information and kind of decide where they want to move forward. So it's a really interesting thing that's happening right now. Of, you know, I'm curious to see where we're going to move on it. And there's a lot more talk on it. Kind of all the conferences that we go to now, it's a hot topic of discussion.
Awesome. Well, thank you. Before I touch on that aspect of counterfeits, which I'll bring up a little bit, I just quickly want to have a follow-up question on you evaluate a lot of innovate and novel battery designs and chemistries. How do you assess them safely, and like how do you assess the functionality and safety of these battery types given the complexities and possibly reaching into a black box and not knowing what's in there?
Yes. So with normal cells, everything's pretty straightforward. But as we're seeing more new chemistries come on, so again, that silicon, solid state, lithium metal, we're seeing more of those come into the lab, which is exciting for me because I love working with those things, but can be a little scary from the outside point of view. And we really do have to have a lot of communication with our clients about what they're bringing to us. So especially prototypes, they're more prone to have construction anomalies. So either tab welding, and that's really not anything to say about the company itself, but more of this is everyone's learning and it takes time to learn. So when we have a failure in the lab, that's something that we find is really beneficial for clients to see why and how their cell failed. So with new cells that come in, because they're from usually a new manufacturer, they're just starting to make up cells, whether they're in a research lab or they have a small manufacturing facility, they may not know proper construction procedures. So that's something that we can help them identify is, do they have proper insulation? Are the tab welds okay? Or the cell alignment, the filling of the electrolyte, how much electrolyte you have in it? These are all things that kind of impact the results of a standards test that we perform or custom abuse testing for them. And it's been really interesting to ask them. And, you know, I respect their what they have in their cell, and that's their proprietary information. But we have gotten to the point where we do need to ask more. So I'll usually phrase it as, if you have a silicon anode, is it under 10% or is it over 80%? Because that will impact how we're doing the testing, especially for our technicians. So with those cells from new manufacturers and silicon specifically, it does have a higher burn temperature than traditional lithium ion. So we test it in a different part of our facility because of that. We've had cells with new chemistries are slightly more prone to have an event during, I would say, normal performance cycling. So just charge and discharge at certain temperatures and humidity. We do see a higher failure rate for some of these. But again, it's new learning, and they're getting what they need out of it to make improvements so that doesn't happen. But because of that, we have to ask more questions about, you know, what type of solid state battery is it? Is it a fully all solid state battery, or is it a little liquid and a little solid? Is it gel? That kind of information helps us figure out how we need to do testing safely.
Thank you. And switching over to the counterfeits question, Randy, with increasing pressure on battery supply chains, there's been growing concern over the prevalence of counterfeit batteries. Uh, has the household appliance manufacturing sector been impacted by the presence of counterfeit batteries, and how has it really impacted household appliance manufacturers?
So let me just start with counterfeiting is commonplace in the market, especially with online retail and that. And so it's very important that consumers are always thinking about the source when they are shopping around. Just don't go to the lowest price, but trying to understand what's there. And AHAM has some good personal experience with this, where we had a very successful anti-counterfeit campaign on replacement refrigeration water filters on that, and drove that all the way through CPSC and Customs and Border Protection. And they're still stopping shipments coming into the country today, even though that program is over 5 years old. So again, counterfeit can have a significant impact on anything, but specifically batteries. Battery technology can easily be defeated. They can be easily made to look like stuff. You can easily knock off marks or whatever that would be. And so the fact that it's just so easy to do that, manufacturers need to be aware. And as I said, consumers need to be thinking about the source when they're buying batteries. And really this comes down to, when we look at the appliances themselves, you were asking about the impact of that. And we've got a subset of the batteries integrated into the product, probably not that much volume or it's specific design. So a counterfeiter is not going to go after that. But where detachable power tool type batteries are being used in appliances because of the leverage of getting a lower cost battery, that's where we're seeing the counterfeits. And so, again, trying to educate, make sure things are well covered from the standpoint of design. I think Emily talked about this a little bit on what could go wrong. You don't know anything about the battery management system within that battery when it's counterfeit. So you just have to look at that. So this really comes back to safety again. So what's the safety of that? Most of the time when manufacturers have looked at fires within products, they go back and start to question whether that's actually their battery, because the consumer does say that the battery had been replaced and issues came up after that. So the industry is obviously looking at additional countermeasures on some of those things. We talked about some of those with the QR coding and certain battery management power assessments that would be watching the battery that may pick up these type of things that could signal that to a consumer. Again, not in products, just being looked at. But I think, to restate, counterfeit batteries are a big issue, big safety issue, a big concern about the product being able to be used for the lifetime of the product. So it's kind of those hidden dangers. Mm-hmm. So and we know that a counterfeit probably is not reusing any materials. They're just going and finding the cheapest stuff, or maybe not even using appropriate materials in there. So performance not optimized. So when we think about sustainability, we know that a counterfeit battery will likely wear out earlier. So just a lot of things that make sustainability harder when you're putting a counterfeit into the equation.
Absolutely. It seems like it'll have significant effects on trying to establish a circular economy for any of these critical materials that might be present within batteries, but as well as just repurposing those batteries. Mm-hmm. Emily, I'll throw this question to you, and it's kind of a similar question. Has the presence of counterfeit batteries impacted how you test batteries? I think you touched on that a little bit.
Yeah.
But, could you expand on that?
So we just have to be more careful. Really, that's especially from our side of things when we have technicians going in. I mean, we're running the abuse testing and the performance testing. We have our technicians going out there and setting up the tests. And we always have meetings every month. And I remind everybody safety glasses. We just got to be careful because with these counterfeits, as Randy mentioned, the construction of them is just, it's so easy to fake the outside. They've gotten surprisingly good at faking the labels and the barcodes. We had to get a specialty barcode scanner to actually read some of these cells that we were trying to determine if they were counterfeit for a client. And from the outside, they looked pretty good. But the barcode, just a couple digits at the end were off, or they repeat serial numbers. That's another thing that they don't alternate them as much as a real manufacturer would. But in terms of testing, the standards testing that we perform hasn't changed. So if someone comes in and brings us cells, whether or not they know them to be counterfeit or not, they still have to pass the same standard that they've come in for. But some people will go a little bit above and beyond, and they want us to look into to find out if it really is counterfeit. So we're luckily enough we have a library of cells that we know to be authentic, and we can compare the cells that we've received to those, and we'll do a full teardown. So we'll do X-ray, look at the label, look at the marking, see if it's registered with UL or any other standard site. And really, when you get in the internals, that's when you can really tell. A lot of tier 1 manufacturers have a lot of little details that they do for traceability purposes. So not even just the cell wrapping has identification on it, but there will be etching on the cell can. So if there is an event that happens, you can still trace back the lot, the manufacturer, the date that cell was produced. Counterfeits do not have that. So if they have a massive issue with the manufacturing that could be at risk of failure, they can't identify the lot of that cells. So it's one of those things that a better manufacturer knows that. Even the buttons of some of these cells from good manufacturers have like microscopic markings at the top of them that we'll check for. But design reviews have really become more prevalent because counterfeits are getting impossible to ignore. They're everywhere, especially with the EV market taking up so many of these cells. Unless you're buying hundreds of thousands or millions of cells, it's really hard to get a cell from a traditional manufacturer like LG or Samsung. So using the design reviews, we're usually able to help clients figure out if the cell they have is counterfeit. But on the other side of that, if it's a new manufacturer they haven't dealt with before, helping them benchmark that cell to figure out which cell they want to use in their product has become a big thing. Because like Randy touched on, people want to buy the cheapest cell, and that's not usually great for sustainability. But with performance and abuse testing, hopefully we can let somebody know if their cell is actually going to last the life that they want it to. And if construction wise, even if it's past the performance and abuse testing that we've done on it, does it pose any concerns? So when we do our reviews, I will never at the end of it say, I believe this cell is safe at the end, but I will give the information, the knowledge that we have from this construction to let someone know if it's consistent with a failure. So in some cases, we've seen that the tabs on the top are completely crunched in and they're pushing in the jelly roll. And that's consistent with a higher risk of internal shorting. So that's something that we can let the client know, and they can compare that with the testing that we've done to determine if they believe that cell is safe enough for them to use in their product.
Well, thank you. That provided us with a lot of hints. Um, I'm going to switch over to Randy on this one because he mentioned a lot about transparency and trying to enhance traceability when it comes to batteries. There's been a growing effort, and as he mentioned, especially in Europe, to establish something akin to a digital battery passport. And this is part of establishing an infrastructure for a circular battery economy. So aside from assisting in the detection of counterfeits, how do you envision manufacturers leveraging this technology to advance their sustainability efforts?
All right, so just a general statement, any steps along the value chain that moves towards this circularity is going to be a positive step for sustainability. So kind of looking at that Europe, and I think I may have said directive, I'm going to just correct that, it's a regulation. Apologize for misstating. I'm not in the region, and I probably used the wrong term there. But anyway, we do have manufacturers that are global, and obviously they're looking at their global footprint and what they need to do. And so what is being done in Europe is going to be transferable, whether it becomes a regulation in the US or not, just from the leverage of that. Regulations could help speed up that activity. But when we're looking at this passport, currently it's only for industrial or electrical EV systems on the EU market with capacity over, I think it's 2 kilowatt hours for that battery, something like that. Again, significantly higher than what we're looking at in the appliance industry. But there's still some good things in this. As I mentioned, the QR code for the battery, making sure that there's a certification mark, UL, CSA, ETL, whoever may be doing the battery assessment, that's on there. And then I think some other key things that could help thinking about this battery passport is the battery health indicator. So this is where within the battery management system, besides making sure that proper balancing is being done, which helps increase that lifespan of the battery, but being able to estimate the state of charge or the state of health and provide that feedback back to a consumer. Again, it's going to make this a little more expensive, but it's going to be more information to the consumer, and they can again see that things just are not keeping that state of charge is not what it has been for the last little while. I think also that passport can help with the overall carbon footprint, material traceability, those type of things as well.
Thank you. I'm going to kind of pose a similar question over to Emily, because in the absence of a battery passport here in the US and sort of a fragmented regime when it comes to that, are there methods aside from what you mentioned with using a library of potential battery types that you've become aware of? Is there other ways to ascertain possibly the origin of battery components or other aspects, or is that kind of dark and mysterious at the moment?
It's pretty mysterious, honestly. It would be great to have more insight into the origin of the actual materials that are being put in these cells, but right now visibility is low, and especially in the testing lab, we really are lucky to get more information just on the general chemistry, but not really the origin of the material. And it was touched on before, but depending on the product manufacturer that's sending in the test, they may not have a relationship with the cell supplier to get that information. They might know that it's a NMC type cathode. They may not know what type of NMC it is, what ratio it is. That might be the only information that they have. So that's the only thing they can give us. And it's important for cell sustainability to kind of have a little bit more knowledge on the origin to know where we're getting it from to make sure it's sourced appropriately. But that's going to be really challenging, especially with the counterfeit market and so many new cell suppliers coming into this space, because it is profitable. And it's profitable because you can buy cheap materials from somewhere. But right now, we really don't have a great way to get that information.
That definitely underlines the importance of just setting up these traceability and transparency mechanisms all the way through. I'm looking at our time. We're getting kind of close to the end. So I'm going to bring us to the final question, and then I'll be asking attendees for some questions of their own. So as our final question to the panelists, and this one's going to be a little bit more open format, and it's for both of you, answer the portions that you feel most comfortable with. But how do you believe that we can greater incentivize greater levels of recycling and second life energy storage for batteries reaching the end of their primary life? So recently, the founder of Circular Energy Storage, Hans-Eric Millen, noted that EV owners are retaining their original batteries for longer than anticipated. Meanwhile, you have other factors such as the decreasing cost of extraction and competition from recycling providers. And all this has made the circular economy a wee bit more complex. So are there similar dynamics present among smaller battery types? And then will the pace of battery innovation help to reduce the complexity of the circular battery economy, or will it kind of create additional challenges for efforts to incentivize recyclers and potentially second life reuse facilities? I'll pose this first over to Randy.
All right, so that's a big one to end with. Kind of a lot of different things there. So I'll just kind of talk about, the pace of the battery innovation and reducing the complexity. And I'm going to, again, being a standards engineer, I'm going to come back to if we can help establish a reasonable foundation of standards and where necessary regulations that include these sustainability principles and expectations, that's going to help ensure a global level playing field for all of us, my members who are manufacturers. And then lastly, kind of the other thing is let's make sure that we're looking at the total picture, safety. We also have efficiency. We haven't talked about energy efficiency and the power it takes to charge these batteries, but then the sustainability as well. So kind of all of that needs to be done and part of this circular battery economy aspect as well.
Awesome. And kind of jumping off of that is it's odd because it's definitely going to increase the complexity. So the more chemistries that come on the market and the more options, it's going to get more complex. But I don't know if that's necessarily a bad thing. I think that's just kind of the growth of any product is you're going to get to the point where you have so many different options. And it's interesting because one cell type or one cell chemistry won't be the end all be all. I don't think we're going to be in a space where we're only going to be using silicon or we're only going to be using solid state. They have their specific applications that they're really well suited for. And that kind of makes things a little bit easier. So if you have solid state, just for example, if it's focused more on large grid energy storage, kind of out in facilities and not necessarily in products, that might be a little bit easier to handle. So you have a smaller influx of those types of chemistries, but it's kind of matching the research with recycling and cell innovation at the same time, which is a very tricky thing to do. And I make it sound so simple, but it's really challenging to get those things to meet together because you also want to make sure that if we're focusing a lot of our energy on a new cell type, we need to think about how it's going to perform during abuse testing and performance testing, rather than the sustainability aspect, just the sustainability aspect. I think with silicon, there was a lot of focus on, in my research included, I'm at fault for this too, focusing a lot on how abundant this material is, and it would make a great battery material, but doing the testing that I do now and seeing how it performs, because it burns so much hotter during failure, we have a new challenge that we have to overcome. So we've pushed for this new chemistry, and it's had this unintended consequence of now, all right, well, what do we do when it's burning at 2000 C? And it's really challenging, but it's exciting to see how companies are kind of tackling this information and growing in it. But it's just, we really have to, I always tell people that testing earlier is better, whether that's in your own lab or sending it to a third party like us. We really want to advocate for test the cells that you have now. So if you're looking at the sustainability or trying to figure out the safety of your product, kind of do those at the same time. It kind of helps you grow a little bit faster and make things a little bit easier at the end.
Thank you. I know that was quite an open-ended question, and it will not probably have the answers to this for at least a decade. But I want to thank you both for helping us look through this. Unfortunately, I don't think we have much time to take on additional questions, but I do want the attendees to know that they can send me or anyone else at the TIC Council some of these questions that they might have burning in the back of their head, and I'll make sure to get them in contact with either you, Emily, or Randy, or we can set forward those questions on over. I just want to express my extreme gratitude towards you guys for assisting us throughout this. And our last message will be that we'll have a recording of this entire meeting available to everyone shortly. Hopefully I'll be able to send something over to you guys within the next 24 to 48 hours, but it'll be publicly available as well. So thank you. And
Much.
this was a great way to start our day.
Yeah, I'm excited.
Thank you.
Thank you.
Bye.